Okay, in this video number 2.2, we're going to learn how to read the atomic symbol. We're going to calculate how many protons, neutrons, and electrons that we have in a particular atom by reading the atomic symbol. And we're also going to be reading electron configurations straight from the periodic table in ground state. Okay, what I would like you to do right now is I would like you to take out your periodic tables and take a look at the very top of the periodic table from the chemistry reference tables. And what you're going to see is you're going to see a box that looks like this. The box is your key, and in that box you have a bunch of things that are labeled. First thing I want to talk about is this symbol that is in bold in the middle of the box. That symbol represents the atom. And each atom on the periodic table is represented by either 1 or 2 letters. If the atom only has 1 letter, then the atom will be represented with 1 capital letter. If the atom is represented by 2 letters, then the first letter of that symbol will be capitalized and the second will be lowercase. The other thing I want you to take a look at is I want you to take a look at this right here that says atomic number. The atomic number is the identifier of that particular atom. In other words, the atomic number tells us what atom we're talking about. If we are talking about atom with an atomic number of 6, that tells us that we will always be talking about the element carbon. Carbon and atomic number 6 always go together. The atomic number is equivalent to the number of protons in the atom. So what it's telling us is that a carbon atom will always have an atomic number of 6. It will also have 6 protons in its nucleus. The other thing that the atomic number is equivalent to is something called the nuclear charge. Nuclear charge. Keep in mind that your nucleus has protons and neutrons in it, and the only thing that has a charge are the protons. The neutrons do not have a charge, so the nuclear charge is also equivalent to the number of protons. So in this particular case, carbon has an atomic number of 6, it also has 6 protons, and it has a nuclear charge of positive 6. Okay, now we're going to look in the top left-hand corner. In the top left-hand corner, we have atomic mass. The atomic mass is given to you right here, and that atomic mass is the average mass of all of the carbon atoms in the entire universe. There are many different carbon atoms. Some carbon atoms have masses of 12. Some carbon atoms have masses of 13. Some carbon atoms have masses of 14. But before we get into that, let's talk about what atomic mass is. Atomic mass is equal to the number of protons and neutrons in the nucleus of an atom. Remember that protons and neutrons both weigh 1 AMU. They have the same mass. They both weigh the same, 1 atomic mass unit. So when we add up protons and neutrons, we get the atomic mass. Now you might be saying to yourself, well, this is not a whole number. And the reason it's not a whole number is because there are things called isotopes. Isotopes are atoms that have different numbers of neutrons, but the same number of protons. So what happens is their mass is different, because they have changed the number of neutrons. Let's take a step back for a second and take a look at how that works. Let's say we have an atom of carbon, and we know it's carbon because it has the atomic symbol C and has 6 protons. The protons are listed right here. Now let's take a look at its atomic mass. Its atomic mass is 12. That means that we have protons plus neutrons that equal 12. I'm going to abbreviate that. P plus N equals 12. Well, we know that there are 6 protons we do not know how many neutrons there are, and it must add up to 12 because its mass is 12. So that means that this carbon atom has 6 protons, and 6 plus what number will equal 12? It must have 6 neutrons as well. If we take a look at this carbon atom, it still has 6 protons. However, its atomic mass is now 14. Remember, this number is its atomic mass. So if we have the mass equal protons plus neutrons, which is 14, and we know we have 6 protons, then in this case, this number right here has to be 8, because 6 plus 8 equals 14. So there must be 8 neutrons in this atom. Each one of these carbons were carbon because they had 6 protons. However, they both had different masses. And those elements that have the same number of protons but different number of neutrons are called isotopes. Remember, if it's the same atomic number, then it has to have the same number of protons. If they have different atomic masses, then they're going to have different numbers of neutrons. These two carbon atoms are isotopes of each other. Okay, so we're still talking about why does this carbon on your periodic table have an atomic mass of 12.0111. The reason is because there's a mixture of isotopes out there in the universe. There's maybe 90% of the time you're going to get a carbon-12 atom that has atomic number 6. And 10% of the time you're going to get a carbon-14 atom. If I average these up, if I took 9 carbon-12s and 1 carbon-14, or 9 times out of 10 I got a carbon-12, and 1 time out of 10 I got a carbon-14, then the average of all the masses, 12 plus 12 plus 12 plus 12, and so on and so forth, is going to be closer to a mass of 12 than it is to a mass of 14. Let me show you exactly how that works. Okay, so what I did here was I wrote carbon-12 down right here. There's your carbon-12. And if we said it was 90% of the time I had a carbon-12, that means 9 out of 10 times I have a mass of 12. So what I did was I wrote 12 down 9 times. 1, 2, 3. You can't see me pointing. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if we said we had 10% of the time we had a carbon-14, that means 1 out of 10 times I had a mass of 14. Well, if I take all of these numbers and add them up and divide by 10, I will get an average. So 12 times 9 is 108, plus 1 times 14 is 14. 108 plus 14 equals 122. Now what I have to do is I'm going to divide by the total that I have here, which is 10. So 122 divided by 10 is 12.2. That is the average mass if I had 90% of the time carbon-12 and 10% of the time carbon-14. Now, this is not the most accurate way to do this because we can't necessarily count and divide by 10. So we do have a way of calculating what we call average isotopic mass, and we'll get to that in another video. However, I wanted you to see that the average that is on the periodic table is an average of all of the masses of all of the carbons or whatever element you're talking about in the universe. So to make things easy, what we're going to do is we're going to take that average, that mass that's on the periodic table, the 12.011, and we're going to round it to the nearest whole number or the nearest tenth in order to keep things simple. Okay, in this case, we're going to get back to basics, what we were talking about before, and you'll see that we have iron here, Fe. Notice that it's one capital and one lowercase, to represent iron. If you don't know what the symbols of the elements are, go ahead and turn the page of your reference tables to table S, and you will see a column that says symbol, and you will see the name of the element right there for you. In this case, what they did was they already rounded the atomic mass for us, so we don't have to guess. It's a 56. It's a whole number. So if we wanted to calculate the number of protons and neutrons in this particular element, we can do so. So let's take a look at iron. Let me erase this. Okay, so if we want to find the number of protons, all we have to do is we have to look at the atomic number. And the atomic number is written in the lower left-hand corner. See, I put this up here so we can see. Atomic number is in the lower left-hand corner. And it says 26. So this element right here, iron, Fe, has 26 protons. Keep in mind they can also ask you what's its nuclear charge, and that would be positive 26. Now we want to find the number of neutrons. Remember, the atomic mass equals protons plus neutrons. If we know that it has 26 protons and we want to find neutrons, all we have to do is the simple math. So 56 equals 26 plus what number? So we're just going to do 56. We're going to subtract 26 from both sides. And we're going to get 30 as our number of neutrons. Okay, we have one more thing to talk about, and that is the electrons. The electrons are given to you on your periodic table in something called an electron configuration. When we look at the electron configuration is telling us how many electrons are in each of the rings. If we recall Bohr's diagram, Bohr made his electrons in specific energy levels, which we're going to refer to as rings. Let's take a look at this picture. In this picture, you have the first ring, which is right here, or the first energy level, and in that first energy level, you have 2 electrons. If you look at beryllium's electron configuration, you'll notice that it has 2 electrons listed in its first ring. Okay? Now we're going to take a look at the second ring. The second ring in the picture, right here, has 2 electrons. One right here and one right here. So in the second ring, it also has 2 electrons. Look at beryllium, right here. 2 electrons is the second number. So this electron configuration is telling me I have 2 electrons in my first ring, or first energy level, and 2 electrons in my second energy level. The total number of electrons listed in the electron configuration, if we added these up, 2 plus 2 would give me 4 electrons. Notice that that 4 matches the atomic number. The number of protons and the number of electrons that are listed are going to be equal to each other. Notice that for magnesium, you have 3 numbers in its electron configuration. The first number tells me how many electrons are in the first ring, or first energy level. The second number, 8, tells me how many electrons are in the second ring, or second energy level. And then finally, the third number, which is 2, is telling me there are 2 electrons in the third ring, or third energy level. 2 plus 8 plus 2 adds up to 12. And so therefore, magnesium has 12 electrons, and it has 12 protons, because its atomic number, or number of protons, is 12. So when we would draw magnesium, let me draw it for you. I would draw 3 rings around the nucleus. In the first ring, right here, there would be 2 electrons. In the second ring, there would be 8 electrons. Don't worry about where we put them right now. And in the third ring, there would be 2 electrons. So that shows you the distribution of the electrons in what we call the ground state. Okay, so to recap, the electron configuration that we have listed on our periodic table shows us the number of electrons and how they are distributed in the energy levels or the rings in a neutral atom. When we say neutral atom, we're talking about an atom in which the protons and the electrons are equal to each other. Keep in mind that protons are positively charged and electrons are negatively charged. So when we have equal numbers of positively charged subatomic particles and negatively charged subatomic particles, the atom overall is going to be neutral. Okay, as a final recap, you should be able to, and if you can't, you need to rewatch this, you should be able to tell how many protons an atom has. You should be able to determine the nuclear charge of an atom. You should be able to determine the atomic mass of an atom. You should be able to tell me the number of neutrons in an atom. You should be able to talk about how many electrons a neutral atom has and what its electron configuration would be in the ground state. And by ground state, I mean the one that's directly off of the periodic table. Okay, until next time.